everyone, and welcome to the third or last discussion on Darcy law under this groundwater engineering course. So, in this one we are going to discuss first about the steady and unsteady flow, how these varies and how Darcy law is applicable. And this flow chart we have earlier seen. So, I am not going to discuss in detail now this. So, first steady and unsteady flow. So, here you can see that the the flow in which characteristics of fluid like velocity, temperature, pressure, density etc., where do not change at a point with time as known as steady flow. So, if it changes like here in case of unsteady flow, both figures might be looking similar, but there are differences. Here you see that these are different velocity, different temperature and different pressure. So, if these changes, then the flow is called unsteady, but if these do not change like velocity, temperature and pressure, then it would be known as steady flow. So, again the flow in which characteristics of fluid which are like velocity, temperature, pressure, density etc., which do not change at a point with time as known as steady flow. And in unsteady flow, which we have seen that with time or at a point it will change. So, flow in which characteristics of fluid changes with time at the same point is known as unsteady flow. So, now we have understood what is steady flow and what is unsteady flow. Getting steady flow is really might be sometimes challenging because these things might change with the distance, but nonetheless we will see further on this. Second which we are going to discuss here is uniform and non-uniform flow. So, a similar kind of diagram is here, but in a non-uniform and non-uniform the difference is that the fluid, which is in our case is water, a flow in which properties of fluid like pressure, temperature, velocity etc., changes with respect to time. However, these properties will not change with respect to position as known in uniform flow. So, there is a difference in the unsteady or steady flow, similarly uniform and non-uniform flow, and steady flow and uniform flow, that there with the a point it changes, but here with respect to position it remains as uniform. So, does not change with respect to position, there with the respect to position it was changing. So, that was the unsteady flow. So, in non-uniform it changes. So, again these values are changing as input values, here these values are remaining same, there is no change whatsoever. And the fluid flow or the water in our case, which is properties of fluid pressure like known as, and which changes. So, as well as with respect of position it changes with time as well and with position, and that is known as non-uniform. So, again the fluid or water flow in which the properties of fluid like pressure, temperature, velocity etc., changes with respect to time as well as with respect to position, and that kind of flow is called non-uniform flow. Now, the third one is the rotational and irrotational flow. So, which we will also see that if a fluid particles flowing along stream lines also rotate their own axis. So, if you might be having here we are talking about the fluid particles means water particles, but there might be some sediments and other things, and which may have may not be completely rounded. So, they may change. So, when they will rotate along its own axis, then the fluid particles will also change, and that kind of flow we say is rotational flow. And if these are the fluid particles or water particles do not rotate about their own axis, then flow is known as irrotational flow. So, generally if it is a laminar flow and a steady flow and uniform flow, then there is likely that the rotational flow will not be there, it would be irrotational. but it depends on various other conditions. Now, another type of fluid flow which we will see in detail is the comprehensible and incomprehensible flow. So, if the density of fluid varies, so now here instead of temperature or position with respect to position or with respect to time, things were changing. Here the density of fluid varies from point to point in the flow, and the flow is known as compressive flow, and if the density of fluid remains constant through the flow, then the flow is also known as incompressive flow. So, because when density is changing, that means the fluid is getting compressive, and therefore, this kind of flow is called compressive flow, and if it is not changing, then incompressive flow. So, with this we end this very brief discussion and also completes the Darcy law part 3, and you would see that there were few sections which were left in our discussion, only 2 points in the flow chart which we will be discussing later on whenever their utility will come under the discussion. So, for time being, I thank you very much for completing or allowing me to complete this Darcy law. Thank you. See you next lecture.